got a high water situation. Our creek is running 3 or 4 inches above normal, a little bit turbid, but our weir here is sandbags and rocks that controls our volume for our 6-inch intake line right here. I've got a little 2-inch thing woggling on a 1/2-inch rod that is the main intake. The water flows from here down to an elbow down here. Here we've got a clean out, gravel trap in the bottom, which goes out the bottom, and we got our elbow in our 6-inch line. That goes then to the intake screen. So a little further down here, we have our spinner screen. Which is running at capacity. The debris flows across the spreader. It's distributed evenly in the top of the spinner screen. The spinner screen is on bearings. I've got golf ball bearings at this end and a pin in the end of the other end. I can stop and you can maybe see the holes in the top of the 6-inch pipe. Those are 1.5-inch holes all across there. The water flows through the screen into the 8-inch pipe. We have overflow here. Okay, I shut off the water at the creek intake to show you how the spinner works. What we have on the end, well, let me take it apart for you. We have just a bolt. We have a bolt in and a set screw, and at that end we have our bearings, our ball bearings, our golf ball bearings. And this is nothing but a screen with a squirrel cage blower off a heating unit, an air conditioning unit. You should make some effort to keep it round for stability. I plugged the end of the pipe with a piece of PVC trim board I had, and a couple of 2-inch fittings to ultra high molecular weight polyethylene bearing there basically, and a stainless steel bolt that just spins in that bearing. So this spins with the cage actually. The water goes through the screen into this basically open spot right here. The water that flows over this section right here engages the wheel, the squirrel cage wheel, which provides just enough force to keep him rolling, and then the debris rolls off the top, all the water goes in and then down to the reservoir. This is stainless steel thin gauge to divert the water downward at the proper level. This is a corrugated pipe. We want a nice even distribution. This is the spreader, nice even distribution of water on here to keep from having high spots and low spots. But this thing works quite well. Today after the big rain, it was overloaded, and if you've got too much water flowing into this, then it'll go outside and it'll stop the spinner, and that's a problem. So I'm trying to do that. That's what this is all about, but it's really not quite large enough. So under normal situations, this works well. You can't overload it. And then from here, the clean water goes into a reservoir tank here. Now here, because we've got high water, I've got an overflow here, which is limiting how much water overflows the spinner screen. In the bottom of here are 2 4-inch lines that you can't see because the water's so turbid. But from there they go 500 feet downstream to the nozzles for the turbine. It's a turbo wheel that will generate about 500 watts at capacity. Right now we've got them valved down a little bit, but I'll show you downstream what it looks like downstream. Here we have the 2 4-inch PVC lines that I've spray painted for camouflage. They have to cross the creek here, so we've got about a 100-foot span where I need to support them in the air. I've got a 3/8 wire rope cable anchored to a rock back there. We use poplar trees for our towers, and they're on the supports from the trees are on vertical chains initially in order to allow the trees to move and not in the wind and not move the pipes. At the top, we ran this cheaper Schedule 20 green pipe up the hill to keep it level and the pressure down. That stuff is not pressure rated. We ran from there down. We ran this more expensive Schedule 40 PVC, where the pressure builds up as we come down the hill to about 16 pounds at the turgo wheel down here by the creek again. We've got another small stream crossing right here. Use the same system with the cable and the trees and the zigzag small lines holding the pipe. Our two 4-inch lines split into twin 2-inch lines. So we've got 4 2-inch lines going to a 4-nozzle housing that feeds a Harlington Green Spoon 22 wheel in the middle of the housing here. I think this is ME 1603. To generate the electricity, and from here we've got 3-phase AC. Then we run through the wires to the little hut up there where the electronics change it to 2-phase DC, and we have our batteries and our inverters. Here we have the electrical components. Right now we're running 24.8 at 17 amps. I've got it valved down a little bit right now because I had some problems with the intake. It'll go on up to a little over 20 amps. We've got our overflow, our emergency diversion heater right here. The rectifier under the lid there is turning the AC into the DC, which then feeds the batteries and the inverters. Right now I have the 400 watt inverter on, which is building voltage in the batteries slightly. Well, it's staying even actually. The 600 watt inverter will go on when I want to use more power. And when I turn on my other nozzle, I'll get more amperage, and it'll feed the bigger inverter. From here, we've got 500 feet of twin 12 gauge, 2 12-2s, and a signal wire going up to the house, which gives me control over the inverters and a voltage reading up at the house. And that's so far what we got, and it's an imperfect system, but it's functioning well at the time.